All right, for this extra help today to prepare you for your retake, make sure you have your original paper in front of you where you did all of your work from your assessment. And we're going to go over the questions, give yourself feedback, and then you'll try an extra practice. So this time, instead of sharing the Canvas screen and writing with the pen on the Canvas screen, I wrote down on a piece of paper what these questions were about, partially because sometimes it's easier for me to write on a piece of paper than with a pen, but mostly because I wanted you to recognize how I would read the question, but then also give myself some little notes on my own piece of paper. As I'm reading my assessment, what can I be writing down that will help me process it better and get a higher score the first time around? So that's part of why you're looking at the paper here. So I didn't write down on this piece of paper every single word of every question, but you can look at it in Canvas as you work on this. Actually, no, you can't because you already submitted it, but I will read to you because I can look at it in Canvas. I will read to you what the original said. Actually, question number 1 was the original question. It just had this MC means multiple choice. So the original question said, the moon has a diameter of about 11,400,000 feet, and you were supposed to choose the correct one that would, the correct one that matches in scientific notation. So here's a tip I want to give you guys when it comes to any multiple choice math question. A strategy that I use is I ignore the options that are in front of me, because sometimes if I look at those too soon, then some of those answers start to convince me. I'm like, oh, I didn't think of that. I think that's it now. And I actually confuse myself. So the number one thing I can recommend for you when it's a multiple choice question is pretend that it's not for a minute. Pretend it's not multiple choice and just solve it as if you just had to write down the answer. So this says the moon has a diameter of about that feet. I'm supposed to write it in scientific notation. So this is what I'd write on my piece of paper before even looking at the multiple choice options. I would go, okay, I know this is supposed to be 1.14, and then times 10 to the power of, I went 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th. I get it written on my paper first, and then when I look back at the multiple choice options, if I see that one, then I feel very confident and I just pick it and I don't even bother with the rest of them. I don't confuse myself. I just move on. Now, if I don't see that one, then something went wrong and I go back and look at my work. Okay, so this is the one you should have picked for number 1, 1.14 times 10 to the 7th. Question number 2, an atom of gold has a diameter. All these first few questions were about diameter. So a lot of these things are spherical, and diameter would be the length like between my middle finger and my thumb there, if you drew a straight line. Okay, so an atom of gold has a diameter of 2.882 times 10 to the negative 9, and it said, what is this number in standard form? This was another multiple choice question, so again, I would ignore the list in front of me and just pretend like it's free response, pretend like it's not multiple choice. So I'm going to remember, okay, 0 point, I'm going to the left because this is getting smaller. How do I know that? Because it's a negative exponent. So I don't have to move past these 882. I only have to move past this one. So that only takes one of these place values. So how many more zeros do I need? Well, 1, 2, 3, 4, 5, 6, 7, 8. And then I put the 2882. And then, yeah, when you go back to the multiple choice, you're probably going to have to be like counting zeros like that. It's fine. But I would recommend with multiple choice, show your work first, get your answer first, and then look at the options. Don't look at the options until you've written your answer down. It really does make you get your answer correct more often, and it makes you trust your results. All right, 3 and 4 were not multiple choice. They said type your answer in, but it's the same idea. So a fish egg has a diameter of 0.00041. What measurement was that even? Meters. Oh, okay, that's why it's such a small number. So this one you had to type your answer in the box, so we have to write it down anyways. We have to see what that answer looks like. So I'm going to go 4.1 times. This is a really small number, so I moved 1, 2, 3, 4. I made that decimal bigger, so this exponent needs to be really small. Really small numbers get negative exponents, 4.1 times 10 to the negative 4. Now remember to type it into Canvas you would just type it almost exactly like it looks here, but it will look a little squished together. That would be the lowercase letter x, 10 to the negative 4. So you write it on your paper, type it into Canvas, no spaces. All right, Jupiter has a diameter of 4.587 times 10 to the 8 feet. Type your answer in. This one said, what is that number in standard form? So these first 4 questions were just assessing, can you move back and forth between scientific notation and standard form? That's one of the important things on this 8th grade content here. Okay, so this is a positive exponent, so now I'm going bigger. All right, so to get bigger, I have to move past those, and they do count as some of my place values. So this is 1, 2, 3, 4, 5, 6, 7, 8. And then in Canvas, you could either type the commas or not. The commas don't matter, but don't put any spaces, don't put any decimals in there because this just got bigger. All right, so questions 1 through 4 were all about, can you move from scientific notation into standard and standard back into scientific notation? First 2 multiple choice, the next 2 you got to type them in. All right, now questions 5 and 6 asked you which one is larger. So it was really a multiple choice question, but only 2 choices. So how would I decide this? Well, scientific notation is really going to help us because you can see I purposefully made all the actual coefficients the same values so you couldn't just compare those. And in fact, sometimes when those are different, sometimes you mix it up even more. But this one is already scientific notation. I'm just going to write it again over here so you guys can see why. It's a number between 1 and 10 times the power of 10. And I would totally write that down on my paper. If I were taking this test, I'd say, oh, that's already in scientific notation. I'm just going to write it down so I have it there. This one needs to be changed into scientific notation. So I know this is going to be 5.82, which is what makes these tricky. Those are the same. That got smaller by 2, so this gets bigger by 2. 2 place values smaller, 2 place values bigger. Now that they are both in scientific notation, now I can really clearly see that that second one is the one I would click. That one is actually bigger because now the coefficient is the same, so all I have to do is compare the place value, and 10 to the 7th is quite a bit smaller than 10 to the 10th. All right, let's try that again. Question number 6, which is larger? Well, I could put these both into scientific notation. Some people say, I can just leave that one standard, couldn't I, and type this one in my calculator? Yeah, sometimes that works. 3.6 times 10 to the negative 6. Sometimes that works. Sometimes it's a lot of zeros and it's a little tedious to read. And sometimes it's too big to fit in your calculator. And so your calculator is just going to give you a scientific notation back and it won't do any good anyway. So what I'm going to do instead is just change this one into scientific notation. So I have 3.6 times 10. I know it's going to be to the negative exponent because this is a really small number. Let's see how many. 1, 2, 3, 4, 5, 6, and then I had to move past the 3 to get right there. So that was 1, 2, 3, 4, 5, 6, 7. That was 10 to the negative 7. And then I would just rewrite this one because it's already in scientific notation. And then be careful with your negatives. The negatives throw people off here. Which one is larger? What's going to be larger, to the negative 7 or to the negative 6? Well, this is going to be one less place value into the thence, the TH stuff, so it's actually going to make it bigger. Okay, with negatives, the closer to 0, the bigger you are. With positives, it's the opposite. The closer to 0, the smaller you are. Okay, so this one is larger, but that's the way I would deal with questions 5 and 6, is make sure they're both in scientific notation, and then I can just compare those place values. All right, then we got into our word problems. And I was the nicest teacher ever, and we were so nice, and we told you hints on all of them. We told you on the side of the word problem, we told you which operation to use. So make sure you're reading everything and paying attention to all of that. I'm going to read you the whole thing. So number 7 was about this. It said a hummingbird's brain has a weight. This is the weight of approximately 2.94 times 10 to the negative 3 ounces. Where an elephant's brain has a weight of 1.76 times 10 squared ounces. So clearly looking at this, whose brain is bigger or weighs more? An elephant's brain, okay? So an elephant's brain weighs more, And the question says about how many times bigger is an elephant's brain than a hummingbird's brain. So this is a division problem. And it said it right there on the problem. How many times bigger? Now, one of the mistakes students make when they're setting this up is they are trying to, they forget that the order really matters. So this gave you a hint that it's division, but if you still got this wrong, it could be because you just tried to write them in order. If you're asking how many times bigger is something, well, you need to start with the bigger one then. So I'm going to put 1.76 times 10 squared divided by 2.94 times 10 to the negative 3. So I need to make sure I have elephant's brain on top because it's the bigger one. Okay, so for these division problems, make sure you have the bigger one on top. And then I put this note over here to remind you that this was a multiple choice question. Okay, so I am going to divide coefficients. I'm going to go 1.76 divided by 2.94, divide the coefficients. And when I look at all of the options in the multiple choice, I don't see some big long decimal like this. I see stuff like 6, 60, 600, 60,000, 600,000. So I feel pretty comfortable rounding that to 0.6 because I can tell from the multiple choice that they did too. So I am dividing coefficients and subtracting exponents. This is a really common mistake, you guys. 2 minus negative 3 makes 2 plus 3. I'm going to write that down here. 2 minus negative 3 is actually 2 plus 3. That's a 7th grade thing. When you subtract a negative, it's really adding the additive inverse. Now, again, when I look at the multiple choice, I see that they're not actually in scientific notation. So I can just type this in my calculator. Okay, so 60,000. 60,000 times bigger, and if you go back to the multiple choice, when you're done writing that down, you'll see that that's one of the options. So again, that's my strategy with multiple choice. It's part of the reason I didn't show you the screen is because I don't even look at the other options until I've gone through the math and gotten an answer. And then when I go back to my multiple choice, I'll feel very confident. When I see 60,000, click that one. Okay, so question number 8, let me read to you what the whole thing said. It said that Earth is 9.3 times 10 to the 7th miles from the sun. Jupiter is 4.8 times 10 to the 8th miles from the sun. What is the distance from Earth to Jupiter? And it told you, hint, subtraction. This is a subtraction problem. So let's set up a subtraction problem. Again, if you're doing subtraction, just like with division, you had to start with the bigger one. That's also true with subtraction. Division and subtraction start with the bigger one. Multiplication and addition, the order doesn't matter at all. So I'm going to start with the bigger one, and I'm going to say 4.8 times 10 to the 8th minus 9.3 times 10 to the 7th. Okay, remember with addition and subtraction, we need these powers of 10 to be the same. Remember, we leave the bigger one and we fix the smaller one. When I say smaller, I mean the exponent. The coefficient doesn't matter. So I go, I need this to get bigger one, so this needs to get smaller one. This gets smaller one, and this gets bigger one. Okay, now I'm actually ready to subtract the coefficients. As soon as you get the powers the same, then you can subtract coefficients. So I'm typing that in my calculator. I get 3.87. 3.87 times 10 to the 8th, and then I double check, is that in scientific notation? Yes, it is. So now I'm ready to type it into Canvas because this was not a multiple choice question. So remember, you would type it in 3.87, use the X for multiply, don't do any spaces, and then 10 to the power of 8. Okay, almost there. And by the way, on these videos, if you're like, well, I got some of these right, do I really need to watch this whole thing? Well, no, that's the benefit of it being in a video is you can jump around, skip ahead, rewind. If you're like, I got all these questions, these last ones right, then great, you're done. Give yourself feedback and go back. If these are the ones you missed, keep watching, give yourself feedback before you do the retake. Okay, this one said that one ant weighs 4.5 times 10 to the negative 5 kilograms. That's a very small number because an ant does not weigh very much. That's how you don't even always know if they're crawling on you. Okay, one ant hill contains this many ants. What is the weight of all the ants in the anthill? And then I gave you a hint, multiply. Okay, here we go. 4.5 times 10 to the negative 5 times 2.5 times 10 to the 7th. Multiplication. Multiply the coefficients. 4.5 times 2.5. Typing it in my calculator. Multiply the coefficients and add the exponents. Watch your negatives. Negative 5 plus 7 is 2. Do not type that answer in. Why not? It's not quite scientific notation. Why not? Because this number is too big. So I need to fix it. 1.125, that got smaller, so this gets bigger. And this is the final answer that you should type in. Okay, one more. The approximate number of people, and I call the population on here, but the approximate number of people in Asia is 4.463 times 10 to the 9th people live there. This is the approximate population of North America, and it asks you what is the total of these two put together. That's an addition problem, but even if you didn't recognize that, it told you. So here we go, addition. 4.463 times 10 to the 9th plus 5.79 times 10 to the 8th. Okay, leave the big one, 4.463 times 10 to the 9th. And this one needs to go one place value smaller so that this can go one place value bigger. And now I'm ready to add the coefficients. Now that I got the exponents the same, which you have to do with adding and subtracting. 4.463 plus 0.579, 5.042 times 10 to the 9th. Pause and double check. Is it scientific notation? Yes, it is. Type it in. If you have any questions, please ask your math teacher, but go ahead and give the extra practice a try, and then you can do the retake.